My name is Sanjay Srivastava. I'm the CEO of Vocareum, and thank you so much. This is our first year at Instructure Con. It's so exciting to be here, getting an opportunity to meet so many of you at the same place. So I'm going to talk about Vocareum, and for those of you who might not know of us, just a quick background. We have been around for 4 years. We started getting deployed in August of 2014, so this is now 3-4 years of deployment in universities. Primarily focus on higher ed, although we have a few, very few K through 12, basically APCS classes. But we are building an infrastructure for computing classes. It's a cloud infrastructure for computing classes. And the reason why we believe there needs to be an infrastructure for computing is because there's some unique things about computing. I mean, one of them, big one, is assessment. If you are going to assess a student's code, ideally you would like to execute it, right? You would like to run it, so that needs an infrastructure. When the students are working on their assignment, sometimes they need some complicated tool suite, and that might require a special infrastructure. Sometimes you might need a lab infrastructure, which has some specialized hardware like cluster. And so far, there hasn't been much of infrastructure or a commercial product like Vocareum, and I believe the reason being that the market was too small. I mean, there's not enough to justify a company just focusing on it. So typically it was being handled. Typically, teachers put together some sort of a grading script, and I see this over and over again themselves. Sometimes graduate students would do it, and they will try to maintain it. If you needed some specialized compute, you'll go to your IT department, and they will try to deliver it. But I do think things are changing. So when Vocareum was deployed initially, it was mostly in the large computer science classes. And what was happening is that computer science enrollment was going up, doubling every 2-3 years, starting, say, 2004, 2005. And at least in the big universities, what they started doing was they started increasing the class sizes. And very soon they started realizing that, okay, they needed some help. They needed some infrastructure help to handle tasks like grading and all that. So that was our first deployment. But what is really exciting right now is what we are seeing in terms of computing in non-CS classes. So one of the 2 biggest drivers for our adoption right now is business analytics. There are lots and lots of business schools which are actually in Vocareum platform teaching analytics. I happened to be a couple of days ago talking to a friend of mine who is a professor at the University of Minnesota and in electrical engineering, and he said the single biggest complaint he gets from industry about the graduates is that they don't know enough coding. I was actually happened to be talking to someone from a small liberal arts, really elite liberal arts college over in New York City, and she was mentioning that even the history majors right now, they're teaching how to do web programming because they believe that when they graduate, it increases the odds of their getting a job as a curator in a museum. And of course, Harvard has a new program at the intersection of biology and computing. So it's been actually a really, really exciting time to see computing now show up everywhere. So on the K through 12, there's a lot of effort from code.org from a government. They're trying to push it down, but higher ed right now, because maybe a little bit more freedom, so it is moving at a really fast pace. So we are seeing a lot of adoption in non-CS. Data science is a big deal, right? So here are some of the programs that were very recently, where the universities have created a data science program. They're giving you a major in data science. So I don't know who I'm quoting right now, but data is now the new oil, which means all of us, need to learn about, become data literate. So I was recently talking to a healthcare analytics company. They have 10,000 plus engineers, and almost overnight, they have to become data scientists. Partially because of IT industry, IT services industry. All of a sudden, because they used to serve these large corporate clients, but now as more and more applications are moving to SaaS and cloud, that part of the business is going away, but the need for becoming more data literate is going up. So, and what is again exciting about data science that it is not happening just in computer science, as you can see here. It's happening at the intersection of math, business, and engineering, computer science. So which means, once again, from an infrastructure perspective, you can't just bring the computer science infrastructure to data science programs. And we'll sort of talk a lot about it. A couple of programs that we mentioned here, Colombia, Georgia Tech, Notre Dame. Good thing about it, they're all on Vocareum. Some of them early ones are not, like Berkeley is not, but they're all in Vocareum. So they're deploying their assessment and development on Vocareum. Online has been pretty exciting for us. So once again, online, when your students are spread out all over the world, and you can't count on them to have an latest, greatest machine, and if something goes wrong, they can go to your local IT, maybe you can get some help. But the student might have any machine, any operating system. So what has been a big deal to provide an infrastructure so they can all that they need is a browser. So for example, up until this year, most of our deployment was residential. But this year, we've done some really large online. For example, Georgia Tech, we'll talk a little bit more about. They had an online intro to Python. Colombia, their artificial intelligence MicroMasters, which is 4 classes, they launched in Vocareum. Colombia also business analytics. So online has been a great experience for us because you have thousands of students come in there. It stresses the platform in a way that typically a small class wouldn't. And also, a lot of students, as you know, audit the classes, so they don't pay for anything, which means the cost structure has to be, has to support that. So that has been a big deal, again, in terms of where we see the adoption. So our solution is to build a highly scalable and in a computing lab, cloud lab, which has some of the key parameters that we talk about. One is, of course, the lowest per student cost. So that has been, most of our innovation goes in to make sure that we can serve. This year so far, first half, we had about 30,000 students. We're expecting it to be 100,000 by the end of the year, and hopefully 1 million next year, which means we would like to be able to serve a lot of students at a very, very, sort of a low predictable cost and deliver them compute when they need it. Improve time to market. So my background is not in education. So of course, the time is semiconductor tool. So we used to use the phrase time to market all the time. But what I'm noticing in education here over the last 4 years of being in it, that there is a need for thinking about pace. So the market needs, like as I was saying, data science or robotics or whatever. If the robots are going to take over the world, you better be programming robots or designing robots. But the pace at which we are able to introduce those programs sometimes is suboptimal, And so what we are as a mission, what Vocareum is trying to do is like saying, can the infrastructure help? Are there friction because your IT can't quickly support it, because the assessment system can't be there, and even the content is not available. So that's a big deal for us. And better educational experience, and we will talk a little bit more detail about it. I had my stopwatch here to make sure I don't ramble on, and I just stopped. So David can give me like a 20-minute or a 30-minute warning. So, yeah, I know you'll give me 10 minutes. Yeah, I just want to make sure that. Thank you. Yeah, just stopwatch somehow starts. So where was I? Talking about better educational experience. So again, since when the students submit their work, you can run some compute. Actually, you can deploy assessment strategy and engagement strategy, which are sort of unique, which are not available in the context where the student is submitting maybe an English paper or taking a multiple choice quiz or whatever. So again, this is pretty exciting to see. So this was not a controlled experiment, but I remember a San Diego Community College teacher said she had deployed one set of classes in Java, intro to programming, and with Vocareum, one other without, or whatever. And I've forgotten exact numbers, but we said a drop-off rate or whatever just dropped dramatically. And her thesis was, again, not a controlled experiment, that the fact that students were able to get feedback really quickly, was really, really key to sort of keeping them engaged. So we are integrated with Canvas as an LTI tool. And we have lots of universities right now using it very, very successfully with Canvas. So the students don't need an account in Vocareum. They can just sign on through LTI, and they get the grades pushed to the Canvas gradebook, right? So here's a concrete example of what the student experience looks like. So inside Canvas, they are seeing a little window, which is Vocareum window. And this is a very simple Python example. So they get Python code. They have some buttons there. on the bottom right, they actually have access to a cloud, a shell in the AWS cloud. So they can run their code. They can run some tests by clicking the run button. They click submit, and their code gets collected, and the script gets run, and the student is immediately given feedback. And also, optionally, we provide an API so that you can set the grade. So once again, in the middle of the night, if the student is working, if they, again, we have seen we have data point to show it right now. Again, this is not a controversial topic, so we are not doing any research on it, that if you give the student the feedback right away, then their engagement goes through the roof, right? So now again, as an infrastructure, you can give them maybe a simple feedback like, okay, here are a couple of tests and running, or your program doesn't even compile. So and this is sort of the very simple Python example, right? And this is, of course, everything is configurable here by the teacher, and we are not showing here. Please stop by for a demo. So what's configurable? What does the student see? What does the interface look like? This is a simple, what we call a terminal interface. What does the student start with? What happens when they click the run button? What happens when they click the submit button? How does the grading happen? That's all specified by the teacher. This is an example, not a great screenshot, I just did it like a couple of hours ago, of a robotics class. This is, again, robotics, again, we are kind of excited about it. This is a Colombia, their MicroMasters, so we worked with them. So robotics, this is a ROS, in the cloud, and we have deployed it. And what you're seeing on the graphical window, that's a robot. You can control it. This is on a browser, and you can write some server code in the bottom. And once again, this is all being delivered completely seamlessly. And when the student hits submit, again, you can go and run scripts. And because it's running in a MOOC, so they can be auto-graded and all that. And the third example here is data science. Basically, you can do all sorts of Jupyter. This is a Jupyter notebook. This is a student interface. You can do all sorts of interesting visualization and analysis. I was hearing about R and PHP and Python or whatever. I'm assuming they're talking about visualization. And so lots and lots of interesting visualization packages, analysis packages sort of there, and you can integrate it in the context of Canvas. So a little bit now about the architecture. This is, at the lowest level is the cloud. This is all built on top of Amazon. Is the cloud compute and cloud storage. And on top of it, we have built these capabilities, for generic capabilities to help with the class, which is things like how do you manage assignment, auto-grading, talk a little bit more about it. Auto-grading is one of the big reasons why people come to us. Content management, plagiarism detection. So plagiarism detection, so we did build a tool for plagiarism detection for coding. Leaderboard, this is a really interesting, very feature that we implemented at the beginning of this year, and we had a class in Stanford and Cornell try it out. And essentially what happens is the moment student submits their work, you write some script to say where they fall on, how good is the performance. And if you compute it, there's an API. You tell the platform, put them on Leaderboard. It is anonymous for privacy reason. Our student can have a screen name which shows up, and so they are placed on Leaderboard. And I'll share some results or whatever. It's just been fascinating. I don't know if the students are learning more or not. That's up to the teachers. But in terms of their behavior and engagement, it just goes through the roof. Team projects, again, this is a big deal. So just about every class that we serve large class, not the online, but the residential classes, they collaborate in teams. And again, the entire infrastructure we provide for the students to work together in teams. And there's a protocol by how teams are formed and everything. Exam management, as someone was telling me, there are only 2 times in your life or whatever as a programmer, you actually don't write code. One is when you take a test, second is when you go for an interview. Because the exams typically don't have the infrastructure how a student can write real code. So, and this is something which more and more teachers have been not been happy with the solution, that you teach them, get them ready, and then when it comes to exam, they still have to give only a paper exam. So there are some capabilities just to help you manage exams. Inline feedback, again, I was going to say it's a very big deal. I'm saying, but I realize that I've been saying this a lot. It's a very big deal. But it is a really big deal, which is inline feedback, that when you can provide feedback to the student in the context of their code. And that's sort of the next level of horizontal capability. On top of it, we split into what we call labs, right? So these are labs right now, are programming labs, big data labs, data science, and I'll talk in the next slide a little bit more detail what we mean by that. There's animation, robotics, and web. And so all the capabilities in the bottom, right, they're all sort of available to all the labs, right? So this is, again, this is built not for professional development, exclusively for education. And then the students can, let me try this here. And then the student can access, as a teacher, you said how the student accesses, what is their interface to the cloud looks like. Is it a terminal? Is it a web? Is it a Jupyter Notebook or RStudio? Those are sort of the interfaces we support right now. And of course, there are web apps for instructors to basically configure it, set all the rules, and then for grader. Lots of energy has gone into this grading app. So make sure that when you're grading the student work, if you're not auto-grading completely, or even if you're auto-grading, there will be some things you'll have to debug, whether some student will say, why did I get this or that or whatever, right? So a lot of energy has gone into as a grading. You can very efficiently go to the student work, run the code, give them the grade, give them the feedback. So that's sort of the overall architecture of the platform. So let's go just a little bit more detail what we mean by that, each of the labs. So programming labs essentially means that the students are learning to program in one of the languages, and they can write their code, they can submit it, they can get some feedback, they can get grades. And we support lots of languages. What's common about it, it's all open source. Some of the languages I did not even know 6 months ago. It's like, for example, I did not know there's a language called Spin, which is, by the way, CMA uses it for teaching software engineering. So something, I don't know what that does still. So lots of C, C++, usual ones, C, C++, Java, PHP, Python, or Julia. All of a sudden, a year ago, I didn't know, but now actually there are quite a few people using Julia. It's a brand new language for doing more sort of for data science. Then data science itself, and what data science for us means right now, couple of things. One of them is the interface. Often they are accessing data through Jupyter Notebook or through RStudio. And the reason why Jupyter Notebook is nice because if you're not a computer science major or whatever, you can just very quickly write a couple of lines of code or whatever, get visualization, get data. You don't have to learn Unix or in the terminal and learn. So that's becoming like super popular. And RStudio, of course, lots and lots of people within the statistics department, business department, they have been using R for a while for doing analysis. And one more thing which data science means for us is to be able to release data sets. So what if you need to release a 10 gigabyte worth of data set for the student to work on, right? So the platform has to be able to handle and manage how do you distribute to 1,000 students, 10 gigabyte data sets, how did they work on it? And as I was saying earlier on, you can't brute force it because you have to deliver it at the cost, price point, or whatever, which the market will sustain. Big data, and for big data, what we mean by that, if you're running these programs on a cluster, we had actually a Penn State class, so using Hadoop, and we're going to be launching a Spark cluster for a whole bunch of classes in fall. And what is not here is now actually deep learning. So a lot of people are beginning to teach like as a part of the machine learning, and what deep learning typically you need a GPU. And maybe some program like, say, TensorFlow or a PyTorch, and sort of that's actually supported. But web development, once again, if you're teaching CSS, HTML, so that's part of support. So the client students can either just do web development, client-side development, HTML, CSS, and all the infrastructure for being able to assess it and them to be able to submit it is all there. Or they can be doing web server-side programming also, so in a PHP or Node.js or Rails, and so that infrastructure they're part of what we call our web lab. Future, if you are if you're teaching cloud itself, or maybe something like a network security. So in that case, we needed to extend our architecture to actually give students maybe for an hour or two, a couple of machines out there on the cloud, which gets provisioned with the super user access and all that, and that embedded in IoT. We're working with a couple of people. Animation and robotics. This is, I think I was just showing you a little screenshot or whatever. That's we are hoping. In fact, it's kind of interesting. Today, I heard like 3 or 4 sort of people came to us and said, we need help with our robotics program. So that's kind of exciting. So we are hoping that while it's not that big right now, data science or business analytics is way bigger. We are hoping robotics is going to be huge as it becomes bigger and bigger part of our economy. And just to drill down, in fact, a little bit more on data science, but I've already mentioned what I was going to say on this slide or whatever, but data science has some unique requirements, like you have to be able to handle large jobs, clusters, using maybe, especially for, used to be Hadoop, but now mostly Spark, and access to all sorts of interesting analysis and visualization tools as a part of curriculum. And data science, once again, what you cannot do is, maybe in a computer science program, you can ask your students to download some complex like a Jupyter notebook and run the server on their own laptop. But a lot of times, since these are not computer science majors, I have heard stories like as much as 1/3 of the class, teachers will set aside to just get students up to get the darn tool installed or whatever, so that learning can start or whatever. And clearly that's inefficient. In our system, it's all browser, you access it, and no setup is needed. So, and hopefully you're getting the hint, like how do we, that we care a lot about cost. And so for cost, what you had to do was we had to sort of develop our own virtualization sort of mechanism, which is unique to education needs. So as next level of details, instead of what will be the easy thing to give every student a virtual machine on a Docker, but that will get the cost up. So actually, we do the isolation at the Unix account level, and at the same time, lots and lots of stuff goes in so that the student writes infinite loops or fork bombs or whatever, it doesn't start crashing machines. And at the same time, you have to isolate it so that they can't see each other's work, but the graders can see it at the right time, and all that has been part of the architecture. And open source has been a big deal. So open source, Vocareum would not be possible, but for open source or cloud. And open source, because my, again, last job was selling semiconductor tools. So with a straight face, we'll go to our customers, semiconductor companies, and ask for hundreds of thousands of dollars of purchase orders. And of course, that was okay because they were making hundreds of millions of dollars every time they design a chip. So as a consequence, when it came to teaching, all the schools were living off like 4-generation-old tools, which was like hand-me-downs from the companies. So it was really sort of every time you talk to all like my friends who are professors, it was really not interesting. But the world which you are living in, it's so exciting that Google goes out there, develops the TensorFlow thing or whatever, and open sources it. Right now, all that leading edge stuff is open source, which means we can deploy it and make it available at no incremental charge or whatever. That's a big deal. And of course, cloud is a big deal because if you go to your IT department and say, tomorrow I need about a cluster of 12 machines and where the student can have run on a 200 gigabyte or whatever, I don't think it would be a pleasant reaction or whatever. And by the way, I'm quoting a real case or whatever, right? So this is the kind of things that you can do. You can get those resources on the spot. And especially with a very aggressive sharing architecture that we have, you can get it done and deliver it low cost. So a little bit about auto-grading. So again, as I was saying earlier on, anything to do with computing has this unique requirement. What's that? 15 minutes, OK. So has this, of course, I don't think I'll be able to finish it all. Please stop by at the booth. So auto-grading, so there's a unique requirement in compute. If you're providing feedback to the students or grading the students, that you need to run it, right? And again, and what it means is that you might want to run it to compare outputs or maybe do some code analysis, do some instrumentation, to provide a student a grade. So that is a part of the feedback. What we call it submission and grading, and essentially in our terminology, what submission means is that you're giving a student feedback when they submit their work, and not for the purpose of grading, but to help them improve their work. And grading is when you assign a grade. So again, as a part of the assessment, what you're seeing here is some code comments. So this is you can go inside and give a comment to the student in the code. So you can go to our website, and it's actually pretty interesting. One of the CSU Long Beach instructor talks about before Vocareum, the way he used to provide them the student feedback. He'd open an email, he open a file, and say, by the way, in file foo.c in line number 17, you had this issue, and line number, and that was very painful. But right now, he can go into the code, insert the comments. Plagiarism detections. So we have integrated plagiarism detection, and again, plagiarism detection for code is unique as compared to, say, English, because the ways students can modify the code, like they can change the variable names. The best story I have heard is that the student took all the variable names and changed from English to Spanish, and or they can insert code comments and all that. So you need some unique. Oh, I did not know this was a video. Thank you, David. So anyway, this is you can get a report which you can compare side by side. So some of the other, just giving you a sample of some of the strategies that you can apply, that you can implement here. It's like mastery learning. The Penn State teacher is implementing it. So basically, his idea is he wanted to make sure the student go through in sequence. And once again, code, the way it happens, we don't know, as a platform doesn't know when the student is done with a step, but we provide an API so you can communicate to the platform, okay, the student is done, now let them go to the next one. So Leaderboard, again, I've talked about it earlier on. So the example which I was giving, there's actually a class of the machine learning with 440 students. I love to give this example. They had 10 assignments, and the teacher implemented the Leaderboard, and the students submitted their assignment 60,000 times. I mean, this is something which I've seen on a platform. So at the very least, even if, on an average, if you have to click the button, submit 1,500 times, whatever it comes down to, just insane. So CMU is the one with they have, as a part of the CS curriculum, and they have written papers about, they had implemented this methodology, and a lot of people are sort of beginning to ask for it. So just a little bit about the business model. It's a simple subscription, predictable. So we are trying to say, regardless of how much compute you use or whatever, it's a fixed price. We do go through lots and lots of discussion on things like FERPA. So as I like to say, after all this contract negotiation, I have a PhD in FERPA right now. Not accessibility, and of course, is a requirement which a lot of colleges sort of have on us. So that was about the learning, and this is something which we're actually launching in fall. So something else which is what we call research labs, and what we're beginning to notice is that even for research in our universities, they needed access to some resources, and typically, universities are sort of an interesting environment because a lot of times you don't need that much compute, but every research group, uses its own operating system and own tool. So it is actually meant for cloud. And cloud is totally optimized for this, right? But there's some issues, like you can't give students just an AWS account or whatever because they might leave the instances running and forget about it and get charged. So we have gone out there and actually built all the workflow and all the resource management on top of AWS cloud and then we're going to be releasing it as what we're calling a research lab. So, and here are some testimonials from our instructor, UCSD. In fact, she was our very, very first instructor. She teaches about 2,000 students a year. Lots of Christine Alvarado, and she has gone through lots of. Anyway, so I'll skip that, and this is from some of our Penn State, USC, UCSD, some testimony from there. Here are some of the universities and we partners, and we can talk more about it. Courses, just to give you a sort of breadth of courses, artificial intelligence from USC, numerical methods from Colombia, and just to give you a sort of sense of, this one was actually really interesting. They're in British Columbia. This was computing for 10 minutes. Okay, thank you. Yeah, I think right on a schedule. So anyway, some classes. This was actually pretty exciting. We did at Georgia Tech a computer. This is a Intro to Python, a MOOC, which also you can take it for credit. So delivered in 2 or 3 different models or whatever. Within 1 week, they had 27,000 students. Right now, like I don't even know, like 1 million submissions and stuff like that, right? And the students are really happy. And Pam, actually from Georgia Tech, she's around, and she's like, this gone really well. Colombia is actually interesting. In fact, we met them at the last Instructure Con a year ago, right here, and they have become sort of a big sort of deployment. And what we like is here is a breadth in numerical methods in the applied math department. Then there's some business departments, CS, the robotics, we talked about it, and there's some optimization methods or whatever, right? So like just to show you, and this is probably where we have the broadest deployment is in Colombia. Notre Dame, so we announced an online masters. We, in fact, just going to be launching like any day now. The first cohort is supposed to arrive, I think, next week for this online master. It will be fully on Vocareum. Before that, they had done this chemical engineering. It was being delivered on Jupyter Notebook and Python, right? So that's the part of this chemical engineering class. So I think that's. Any questions? I think I have 5 minutes for questions. Obviously, I can take questions in the booth. Can I? Yeah?
So you have a lot of university courses and things that you're working on. I dealt with high school courses. Is this something that could be implemented in K-12?
So, we have a few APCS. I mean, actually, we have one APCS, like a Chicago Oak Park in high school. They're using it a couple of years. So we're finding, and so when in fact 3 years ago we had high school deployments, pilots, and we have colleges, and we had to make a decision which way to go, and we decided to go to higher ed or whatever, and a couple of reasons, right? Partly just a sales channel, selling to districts and selling to universities, like we had to focus somewhere, right? And the second thing is that what we're noticing is that the platform does need to be programmed. So a lot of times the high school teachers we're finding like they just don't have enough time to program it. So at least it felt like the right way to go to market strategy for high school would be you come with the content, you partner with the publisher, or we're talking to PLTW people who are here a part of the curriculum or whatever, right? So I'm just being worried about it, dropping it in the hands of a teacher. It just might be too much or whatever. So we will sooner or later hopefully partner with the curriculum and content provider and provide a kind of sort of a ready to go solution out of the box. And the good news is you can do that. You cannot do it for higher ed because, as you notice, I mean, how much content can we deliver, right? We can't deliver CS1 or deep learning or robotics or whatever. But high school, K through 12 is more limited. So the good news is that you can say, okay, let's go APCS, let's go programming principles or whatever, and the first. So you can actually, it's a much more contained space to go and deliver more finished in a complete product or whatever. Anything else? Yes? That is correct. That is correct, yes. So the content is all developed by the faculty member. And so that's why you will notice lots of big research schools, because they throw their graduate students to go out there and develop it,
You're not using Linux, then? You're not doing anything with Linux?
With Linux? No, it is. So if you wanted to teach people Linux, that was a part of what I was saying, the kind of a cloud lab. We are launching it in like a month or so, where you will be able to, for network security, for teaching cloud, or for teaching Linux, you'll be able to give students a machine where they can work on it and grading whatever. So right now, no, but I think in a month or so, we are launching that. So they will do the submission here for sure. For development, they have a bunch of choices, either to work on our platform, work on their own machine, upload it, or upload it to a Git repo. So if we have integration with the Git repos or whatever, so we'll pull it from there. So all sorts of ways. But submission happens. Submission and assessment for sure happens on our platform. You see the end result and either grade them manually or set some scripts and all that, yeah. Well, thank you so much. Okay, that's